So this question says that during an air show, the path a stunt dive of a jet can be modeled by the function h of t is equal to t squared minus 9t plus 81, where h of t represents the height in meters above ground after t seconds. The end of the stunt occurs at its starting height. Okay, and so that right there, that's important information. So basically the jet goes back to the height that it started at. So here's the question. When the function is graphed on a graphing calculator, the height of the jet above the ground at its lowest point can be determined by calculating what? Okay, well, let's think about this. Well, this is, if we graph this out here. Now, and I don't even know much about what this function looks like, but I know that it's a parabola that opens up. Okay? It's a parabola that opens up here. So it's, I don't know, something like this, very likely. So when the function is graphed on the calculator, just read this again. The height of the jet above the ground at its lowest point, okay, well, the lowest point is right there, can be determined by calculating, well, what is that? Is that the x-coordinate of the vertex? Well, that actually doesn't give the height. That is the time, okay, because remember, if you look back at our function notation, it's h of t, h of time. So this is the kind of the time axis. This is the time when it reaches its lowest point. The y-coordinate of the vertex, well, that's this part right here. And that is the height. So that's, I'm assuming it's that right there. Now, it's not the y-intercept, okay? It's not the y-intercept because the y-intercept is where it crosses the y-axis, and that's going to be, that'll correspond to where time is equal to 0. And that is, like, by definition, the initial height that it is. So that's not it. And the maximum value, well, based on what this graph is doing here, there really isn't a maximum. It's going to shoot up forever. So yeah, that looks like it's going to be B, the y-coordinate of the vertex.